Greetings and welcome. We're taking a look at hyperbolas, in fact. Hyperbolas. And we're on page 650 in our text. And here I've got an equation. I want to find all of the important information about it, the center, the foci, the vertices, the equations, the asymptotes, and the graph. So, taking a look at this, let's try to figure out what information I know. So first of all, do you guys think this is a horizontally or vertically oriented hyperbola? Why? Oh, whew. All right, I'm glad you guys caught my back there. I was going to say the y because I saw the big 49 there, but that's kind of like a negative 49. So good catch. Wow. I was seriously just going to start doing this the wrong way. Nope, it's not horizontal. Horizontal. There we go. All right, let's see. Get my brain out of this funk already. All right, so A is going to be the square root of the positive fractions denominator. So square root of 4 equals 2. Oh, no. A little bit of lag. We're recovering, though. B is going to be the square root of the negative fractions denominator. So that's 7. I can find the value of C. C squared is going to equal A squared plus B squared. So 4 plus 49. So C is going to be the square root of, what's that, 53. I don't think that reduces. No, it doesn't feel like it. Oh, wait, what? Question, comment? No?
Oh, okay. So you add the
A squared plus B squared, or I just steal them. Oh. No, yeah. So it's A squared plus B squared, so yeah, it's definitely going to be the non-square roots. Oh, really? Wow. Intriguing. So let's see. So that's the value of C. The center is 0, 0 in this case because there's no x or y attached. Number with the x and y attached to those. The vertices, let's see, this is horizontal, so I'm going to add and subtract the a value to the center. So 0 plus or minus 2 comma 0, which would give me 2 comma 0 and negative 2 comma 0. The asymptotes, I sometimes save those till the end. But let's see, it's going to be y equals plus or minus some slope times x minus h, which is 0, so times x, I guess I don't even need the parentheses, minus plus k, yeah, and k is also 0. So let's see, I've got to ask, is it going to be up b over a or up a over b for the slope? And because it's horizontal, that means a is the over amount, right? It's going over a units, and it's going to be going up b units from the center to find the equation of my asymptote. So it's b over a in this case, I believe. And I never memorize it. I just kind of think about it every time. So 7/2 hopefully is the equation of our asymptote. Let's see. Do I have Geometry Sketchpad open? I'm just going to get myself a nice little grid here. Oh yeah, I got to find the foci as well. Good call. Good call. Let's see. A and B aren't very large. Let's see. B was what? Was it 7? Yeah, it might be. Hopefully this is big enough for us. Yeah, and I'll find the foci next. Okay, here we go. And the foci, yep, forget all about them. I'm just going to add and subtract the square root of 53 to the x coordinate of the center. So I guess I could just write plus or minus the square root of 53 comma 0. Right, so there's 2 of them. Square root of 53 is probably 7.3-ish or 2-ish, something like that. So let's plot our points. So here we go. Center is 0, 0. Right? What do I got? What do I got? Value of A is 2, so I'm going to go over 2 in both directions, like so. The value of B is 7, so I'm going to go up 7 and down 7. And I kind of want to draw this, I guess, imaginary box here. Let's see, is that dark enough? Probably not. And this is going to be kind of, it's through the corners of this box that I'll be able to draw my asymptotes. Oh, too far down. Good enough. So my asymptotes pass through the center, and it would look something like this. Whoa. Get some curve going there. Whoa. And I'm driving out of control. There we go. So that's good enough. And then the actual graph itself starts at the vertex and approaches the asymptote and gets infinitely closer to it over time. Like so. And just like with circles or ellipses, I actually draw one kind of quadrant of it at a time. So that would be my graph. The foci would have been, what, C units away? So what was that? What did I? Yeah, so it was 7 something. So the foci are all the way over here. Wow. Yeah, we should know where the foci are. So what this is claiming is that this distance and this distance, if I subtract them, so if I swung this around and subtract them, I'd get kind of this length here, and that distance is constant. Which, yeah, so if I went from this point to that foci and this foci to that and subtracted this distance from here, well, I might believe it's something like that. Let me actually see. Well, I could actually show you guys how to graph this for real, if you wanted. Want me to graph this? Show you how to graph this real quick using technology? Let's do that. So what is it? X squared over 4. This will be a good example for it. So x squared over 4 minus y squared over 49 equals 1. What I would want to do is actually solve for y. So I would subtract the x squared over 4 from both sides. And I'm going to get a really ugly looking equation, but this is the only way I'd be able to do it. Equals 1 minus x squared over 4. I could then multiply both sides by negative 49. All right. So this would be y squared equals negative 49 times 1 minus x squared over 4. And then I would root both sides. And plus or minus, don't forget it. So what I would end up having to do is I'd actually have two equations. I'd have y equals the positive square root of that thing. Wait, there's a plus sign here. No, it was multiply, wasn't it? Yeah. And that's not squared. And then, so I'd have the positive version and the negative version of that. So let me open up the old sketch pad here, and I'll graph it for real. So graph. So I'll have to enter in the square root of negative 49 times 1 minus x squared over 4. And it looks like I've got the right thing. And if I graph this, this is the positive square root or the principal root. It's actually going to graph the top half of this parabola, hyperbola, sorry. So you can see the top, just the top half is plotted. And then if I graph, I wonder if I can just do negative times negative 1 times this. I bet I could. And there's the bottom half. So the negative square root of that gives me the bottom half. Display line style medium. So that's the idea, is in order to graph it, because this technically isn't a function, it doesn't pass the vertical line test, that we'd end up kind of having that. Actually, I didn't do bad for my graph, I don't think. It's not too shabby. But yeah, so to actually graph this using a calculator or technology, you have to solve it for y, and you end up having two separate equations that you have to enter in order to get the whole picture. But yeah, so we did pretty good on that, I'd say so myself. So let's keep going. Alright, here we've got a problem that's got a clue. Clues, let's see. So they say the center is at 4, -2. So that's my h and k. Wow, I know a equals 2, I know b equals 3, and it says it has a vertical transverse axis. What does that mean for us in terms of the orientation of the hyperbola? The y is the positive fraction, right? So this is a vertically oriented hyperbola. So it's going to be a y minus k squared over a squared minus x minus h squared over b squared equals 1 is the form that I'm plugging this into. So let's just do that. So I'll have y plus 2 squared over a squared is 2, 2 squared is 4, yeah, minus x minus 4 squared over b squared, there's the b, 3 squared is 9, equals 1. And we've got a fire drill, so thanks for watching, internet friends. Bye-bye.